Right, welcome back everyone. My name is Ralph Dolmans. I'm a OARC PC member. In this session we will have 3 talks, all operation oriented, and the first one is from Han Zheng from Salesforce, and Han is going to talk about deploying DNSSEC in a large enterprise.
Okay, good morning everyone. So today I'm going to talk about deploying DNSSEC in a large enterprise. So this talk will cover 3 parts. Okay, so the introduction, and then I'm going to talk about some challenges and successes to deploy DNSSEC in a large enterprise network. And then at last, I'm going to give some takeaway for our talk. So there are some reasons why a large enterprise may want to deploy DNSSEC. The first reason is for compliance. So at the US, we have FedRAMP, which is a compliance that requires, which is a requirement for some customers. And although we are mostly aware of this US FedRAMP, some other countries may have similar regulations too. And ICANN has also advised all should just deploy DNSSEC. And another important reason to deploy DNSSEC is to increase trust for the customers. So when we deploy DNSSEC, there are 2 options. We can deploy it to separate small namespaces for different groups, or we can deploy DNSSEC for all. So at Salesforce, we have many entry points where the customers can access their contents or to log in. So we decided to deploy DNSSEC for all. So first, I'm going to cover some characteristics for our enterprise. So at Salesforce, we outsource our DNS services to external DNS providers to get sufficient authoritative footprint for resolution. And we also use multiple providers for resilience, especially for DDoS attacks. And our zones, some of our zones are very special. They are very dynamic, which means we have up to 1 million changes per day, so that is equivalent to 700 changes per minute. That is the aggregated number for all these zones. And these dynamic zones are not unique. Think about the other companies like web hosting or maybe Alibaba also have similar situations. They also have dynamic zones. But these dynamic updates will introduce some update propagation delays. And we have given a talk at DNS-OARC 27 to cover this, so please refer to that talk for more details. And on the other hand, our zones, some of our zones are very large. Even before signing, they have millions of records. So now I'm going to cover the challenges and the successes. There are 5 challenges. I'm going to talk them one by one. And the first one is to prepare to deploy DNSSEC. So before we deploy DNSSEC, we want to know which vendors satisfy our requirements. And my colleague Pallavi and Shuma have given a great talk at DNS-OARC 28 to compare DNSSEC services and features from multiple DNS providers from different perspectives, including zone setting algorithms, zone size support, and so forth. And our conclusion for this is we had to migrate some of our zones to satisfy some requirements. So migration means we move some of our zones from one vendor to another. And even before we migrate our zone, we want to do some analysis for these zones that will be signed. So some of our zones have been used for a long time for different purposes. So we want to do some cleanup work to remove the unnecessary domains from these zones. And we also look into the subzones for the non-standard DNS features. For example, the traffic management, web forwarding, GSLB, and redirects, all these non-standard features. And we move these non-standard records to the child zones if it's not already there. And the last step for preparation is we want to do some function and performance testing. So we profiled the DNS updates at Salesforce for both off-peak hours and the peak hours in terms of the updates distribution And we simulated all these scenarios and measure the performance from the API usage, server load, and update propagation delays. And when we have done all of these 3 steps for preparation, we have a good idea of which zones to be migrated to which vendors. The next challenge we have is how to select the proper DNS model. So ideally, we should apply multi-signer. And my colleague Shoma has given an excellent talk to cover 2 models for these multi-signer DNS models in DNS-OARC 30. But this model is not available right now. So that's why we apply the following 2 DNS models. So as I described earlier, we have some zones, and they have different characteristics. And we categorize our zones into 2 groups based on how critical this zone is, how large the zone is, and whether we want to host the keys, or the vendors can generate some keys. The first DNS model we apply is the hidden master model, which is a traditional one. So in this case, on the left side, it is a zone update originators, but it's not arbitrary. It can be our code product or operation team scripts or just a curl command. And in the middle, we built an in-house REST API to take the input from this zone updater. We also built an in-house hidden master, which received updates from the REST API and also do the signing. So after we sign the signed zone will be transferred to 2 DNS vendors to serve our customers. And the second DNS model we apply is the third-party signing vendor model. In this case, the updates are sent from the DNS updater originators to the vendor C's REST API, and then the REST API services do the updates to 2 different infrastructures for the same vendor. And then this vendor C, 2 infrastructures do the online signing. As they are separate infrastructures, we consider these 2 infras as different providers, so we still have resilience, especially for DDoS attack. So now we have a good idea of what DNSSEC model we want to apply, and we do need to migrate some of our zones from one vendor to another. The next challenge is how we can do this zone migration. So as I just covered, the main reason we want to do the zone migration is we want to have some vendors to satisfy our requirements. And another reason is we want to do some cleanup to remove the unnecessary domains from these zones. And the first question is whether the zone migration is simple. It should be simple. Ideally, we can just cut off the DNS updates, the REST API service from the current vendor to the new one. And then we change the DNS record. So that sounds very simple. However, when we push this simple button, it will be a disaster. The reason is on the zone update originators, because of the code release cadency, the code release takes time. And at the same time, when we change the NS record, it takes time because of the TTL. So we found it's very risky to do this hot over for live and production and dynamic zones. If we do this simple cut off, both provisioning and the resolution will be broken. So our goal is to mitigate the risk by doing multi-step migration, which will be covered in later slides. And our observation is we want to separate the migration and the DNSSEC signing to minimize the impact. So our goal is to avoid any impact for provisioning and also resolution. And again, we are doing this on production, dynamic, and live zones with lots of customers. So in specifically, our goals are handling the time when we deploy change NS record, and also handle some issues about delegation and subzones and any surprises when we do the zone migration. And all this will be covered in later slides. To mitigate the risk, we want to be prepared. We always want to have a plan for rollback. If something bad happens, some service is broken, we want to roll back as quickly as possible. And I will also cover this in later slide. and some analysis was needed to make sure the rollback was possible, or it was hard. To migrate the zone, we have these 7 steps. The first step is the original status. We have the zone update originator sends DNS updates to the current vendor. The first step is we onboard the zone from the new vendor to the from the current vendor to the new vendor. But as you can see, it takes time to onboard the zone, and during this time, because it is a production zone, we miss some updates because it takes time to onboard the zone. And we call this inconsistency. We will handle this inconsistency in later step. After we do step 1, we want both current vendor and new vendor to have the input, the DNS updates from the zone update originator. But the problem here is we miss some updates in step 1. For example, we create some domain in step 1, and then we update it. In this case, the new vendor will fail. So to solve this problem, we introduce the active-passive mode. So that means the DNS updates are sent to both current vendor and new vendor, but the updates go to the current vendor is active. That means if the update fails, our code will receive error message and handle these errors or exceptions. But on the other hand, the updates go to the new vendor is passive. So that means if it fails, we do not care. We will handle this failure in later step. So after we do step 2, we have almost the same copy of the zone files on current vendor and new vendor. But the new vendor misses some updates. Will be handled in later step. The step 3 is we initiate the DNS-OARC, we sign the zone, but we do not publish DS record. That will be the last step. So at step 4, our goal is to have exactly copy of the zone files on both current vendor and new vendor. But as I just mentioned, we introduced some inconsistency in step 1 and step 2. We need to handle this inconsistency. The way we do this is we have some script to download the zone files from new vendor and current vendor, and then we extract all the different records. After that, we do resolution on the current vendor and Usenet as the ground truth to fix the new vendor records. After we handle the inconsistency and change to this active mode, which means the updates go to current vendor and new vendor. If any of them fails, we consider the transaction is failed, and we roll back the ones that have been done. After we do step 4, we have exactly the same copies of the zone files on current vendor and the new vendor, and we are ready to move to step 5, which is to change DNS records to the new vendor. The step 6 is we do the cutoff for the REST API service, the DNS updates, from the current vendor to the new vendor. After we do this, the DNS updates will only be sent to the new vendor, and our customers can see the answers from there. And the last step for our migration and deploying DNS-OARC is to publish the DS record. And after this, we are done for this specific zone. And when we do the migration, we found a challenge for this delegation and child zones. So this means the zones being migrated remain on the old provider until the entire migration is completed. Specifically, this means if both parent zone and child zone are on the same vendor, but only the child zone is migrated, then the old vendor still serves the queries for the child zone, even we change the NS record. To solve this problem, we introduced several solutions. The first one is we can remove the child zone from the current vendor. And the advantage for this is we don't have to handle the inconsistency, the outdated records. And the shortcomings are it's hard to roll back because the zone needs to be reinstalled. And the customers will see inconsistency record there. And the second solution is similar, but instead of removing the child zone, we suspend the child zone for the REST but in this case, the REST API service will be broken. And this requires some downtime, and it's also hard to roll back. Our third solution is we migrated both child zone and parent zone at the same time. And the advantages for this are there's no downtime and no impact for the REST API service. But shortcoming is if something bad happens and we need to roll back the zone, we have to roll back, change the DNS record for the both child zone and parent zone. So as you can see, we do a lot of work here, and there are some risks. And to mitigate the risk, we want to have a rollback plan. If something bad happens, we can roll back change as quickly as possible. The first thing we want to roll back quickly is to change the modes between passive active and active very quickly. And we use an internal service that can define some simple parameter and make quick change. And this will be effective for 5 to 10 minutes. And another thing we want to roll back is the DNS record. The default TTL for DNS record is 24 hours. And we reduce this TTL to 30 seconds and make the 2 days before we make the DNS change. And a potential issue here is the .com TTL. The .com TTL is 48 hours, but based on our observation test, the impact is not as high as 48 hours. And now I'm going to cover the fourth challenge, which is the NDNS specific challenges. The first one is the signing jitter. So when the zone is signed, the resigning happens periodically. And if they happens at the same time, there will be a loss of access hours to the secondaries. And the stack vendor helped to create a strong jitter to help to solve this problem, but it introduced a bug. The left side figure shows the distribution of the RC expiration times before they fix this problem. And as we can see, all the RC expires at the same time, and that will introduce a lot of XFRs and the propagation delay. And the right figure is the distribution after they fix this in the new patch release. And another set of DNSSEC specific challenges are the NSEC3 support can be awkward and it's hard to debug. So we discovered some bug for incorrect negative proofs, and one public resolver was unable to properly authenticate the responses for records for some certain complex configurations. For example, the CNAMEs that cross zone boundaries or a combination of secure and insecure delegation in the chain. As we apply this hidden master, we found adding and signing the zones for hidden master can be complex. But automation helps avoid human errors a lot, and we highly recommend to do some pre-delegation, and we love to use DNSBs to do this. The last challenge for deploy DNSSEC is a hard load balancer, and my colleague Nida has given a great talk for this in RIPE 79. Basically, we have some challenges to deploy the DNSSEC on F5 GTMs. But Nida worked with F5 people to fix these problems very quickly. And please refer to this talk for more details. And at last, I want to conclude our talk and give some takeaways. The first one is there are some challenges and surprises when we deploy DNSSEC in a large enterprise. But this can be done, and hopefully our talk can shed some light on this path. And second is the DNSSEC deployment needs some work in addition to DNSSEC specific tasks, like preparation, cleanup for the old zones, and the zone migration. And also we need some monitoring to make sure we are doing this correctly. The last takeaway is for DNS KMOS burden. So this DNS KMOS burden from the old standards is also tough, including the delegation issues and XFRs issues we have just discussed, but this is different from the burden of the new standards. And at last, I want to say thank you, and this is a teamwork. Our team members on our team are authors, not just Alison and me. So I want to say thank you to Pallavi, Sarah, Shuman, Nida, Tim, and Paula. We also want to say thank you to all the engineers and product managers at our vendors who have given our great support. Although we anonymize the vendors, they know who they are. And now I think we are open to questions.
Hi, I'm Suzanne Wolf from Public Interest Registry, but I'm actually standing up here as the co-chair of the DNS-OARC working group in IETF. There's actually a draft I know that your team worked on that covers a lot of what you've been discussing as far as what the models are and what the key tasks and so on are. We just kicked off a working group last call for that draft. We're trying to go ahead and get it published as an informational RFC, but it's an educational document, and it needs review from folks like the ones in this room, you know, the people that are either going to find it useful or not as far as going ahead and doing this kind of work for themselves. So for anybody who's interested in this topic, please review the document, and if there are major omissions or places where it's confusing, it would be really helpful to the working group to know that before we try to publish it. So go take a look at it, and Schumann can also, as one of the authors, can talk to you about what's in it. But it would be helpful to have the review. Thanks.
Yeah, thanks.
And this is Schumann, so I just wanted to quickly follow up. I wanted to mention the name of the draft in case you haven't seen it. It's called Multi-Signer DNSSEC Models. Thank you.
Hi, Victor Duchovny again. I've been informally sort of urging people on various lists and forums to treat NSEC 3 minimally, and that is no salt, 0 additional iterations as a best practice. What are your thoughts around sort of trying to eke out more privacy or whatever confidentiality of your zone from NSEC 3 than you get just from the one SHA iteration? My take is that once you've done the first hash, you've discouraged all the casual zone walking. Anything else is fiction. And that really you want to then optimize for performance. So my thoughts, perhaps even to the room, are NSEC 3 additional iterations are a waste of everyone's cycles, pick 0. And salt's largely unworkable, make them empty, and then NSEC 3 performs reasonably well. Do you have any experience that suggests otherwise?
I don't think we had too much experience on the salt and the iterations. So maybe Schumann, you can.
Yeah, so this is Schumann Hook again. So Victor, I think I generally agree with you that NSEC is not a bulletproof defense. You deter casual zone walkers. So I think I'd have to go back and check, but I believe what we did on our production Salesforce zones is that we actually did what you said, which is 0 iterations, but we actually have some sort of salt because we thought it has some use thwarting rainbow tables and things like that, right? But
I don't even think it helps with rainbow tables because every domain is already part of the hash. Mm-hmm. So you can't build a rainbow table across multiple domains. If you don't change the salt frequently, it's kind of pointless, in my take.
Yeah, okay, fair enough. That's a good point. So yeah, I mean, I don't know if you're asking the question generally to the room as well, but that's...
since you guys are...
Okay.
Right. Yes, in a way to the room, but since you guys are actively doing this, sort of leading the pack, as it were, I'm curious whether your experience is different.
Yeah, so the other comment I would make is, so you probably know that some Salesforce people and some VeriSign people and other people collaborated with researchers on NSEC 5 as a way to actually provably prevent zone enumeration, but of course, that's, the DNS protocol engineering community doesn't have the appetite for that big of a change, so I don't think it's ever going to happen, sadly. But the other thing I would mention as far as protecting the contents of zone from disclosure, which is important, which hasn't been deployed in the field right now, is what we do is we operate back-end hidden masters that are sending zone transfers to commercial managed DNS providers distributed around the internet. And those zone transfers are going on in the clear, and they should be protected. So we have another draft, which I'll mention, that Han has worked on, which is XFR over TLS, which should solve that problem.
Yep.
Right. Are there any more questions for Han? In that case, let's thank the speaker.
Okay, thank you.
A request to everybody to please rate this and all the other talks. You can find the link to the survey on the OARC 31 webpage. Up next is Joe Crow. Joe is he works for Comcast, and he is going to talk about DOH and DOT at scale.
Green button. That's the laser. The other green button. There you go. Hi, my name's Joe Crow. I'm from Comcast. I'm a senior engineer there. I've been there for about 4 years, actually, no, close to 5 years now. And I'm on the core network services team. We mainly do DNS and NTP. We run all of the DNS infrastructure. And one little thing about me, in March, I'm going to have another baby girl. Comcast DNS queries at a glance. I know a lot of people have seen these slides before, but we have exceeded 600 billion queries per day. We were usually around 550. That's about 10 million queries per second that we see across our footprint. So that's a lot of queries. In our current infrastructure needs, we need to have capacity to handle all of those UDP packets with the splattering of TCP here and there. We need to do DNSSEC validation and have full dual stack support. And we need to have a load spread across our footprint so we can get low latency for all of our customers and have a better customer experience. And we are expected to have a 100% uptime, barring any network issues that happen. We want to make sure that DNS is always going to work. Within our infrastructure and how we do our Anycast, we've been pretty on par with being up about 100% sometimes. So my talk is about DOT and DOH. We know that's a big hot topic around here, and so let's encrypt all the things, including DNS. Why not? Should we encrypt it? The potential gains are, protection from man-in-the-middle of attacks, resilience against DNS response modification. We're already in that with doing DNSSEC currently, but this is another way that we can protect that data and make sure that it's secure, and improve DNS privacy for customers. And it's all dependent on who's running those endpoints, those encrypted endpoints, and how that DNS data is going to be used. We do care about your DNS privacy. We recently released a privacy policy a couple weeks ago, and in that privacy, we state that we do not sell any of the DNS data. All DNS queries do get purged after 24 hours, and if we need to use them for any lawful purposes or research of DDoS attacks, we will use it for those purposes only. We've never sold any of our DNS data to anyone, so we do, as of a week ago, have a privacy policy about all of our DNS data and web data that Comcast is currently using. We do provide opt-in services for DNS that are DNS-based, that offer parental controls and protected browsing for our customers. We have been doing DNSSEC validation since 2012, and we're currently looking to do DOT and DOH and provide that to our customers. Yep, that's right. We are going to do it. So our concerns are just like anybody's. How are we going to offer this utilizing our current infrastructure? How can we ensure the best customer experience? What tools are available? There currently aren't a lot of tools available to do, at least for DOH, how we can do stress testing. What happens to all of the users? What happens when browsers and applications start using DOH as a default in their services? And what happens to our customer experience at that time? We are currently in a beta doing functional testing. We started on the 22nd of October with DOH, and then a few days later, a week later, we started a DOT trial as well. Those endpoints are open to the public, so I encourage anybody to test them, reach out to us, and let us know what you find. We are currently trying to make this a better product for everybody and be good netizens and share some of the things that we find with this. Our beta 2 will probably be towards the end of Q4, and that's going to be performance and A/B testing. We've got a couple of different infrastructures and test beds that we're looking to implement and test with, and we're trying to do more of the performance testing against both of those after we get a lot of the functional testing done. And we'll probably deploy this sometime in 2020. Of course, we all know in big corporations, things like that might slide. So we are being a little fast and loose on the betas, but when it starts getting to production side of things, we will definitely make sure it's the best product for our customers. General concerns. Our new infrastructure needs. We're going to make sure now that our new infrastructure can handle a TLS offload and multiple TCP connections. Right now, all of our servers just mainly do UDP, 600 billion queries a day. That's if we start trying to translate a lot of that to TCP, there's a big cost on our servers. And how are we going to make that work? We need to figure out the best geolocation for our customers and latency as well. We are aware that initial latency we might see on the first connection for a DOT or DOH request, and then after that connection's made, we might see better responses for queries for the customers and on our servers. But we want to make sure that we get that down as low as possible, even on that initial connection. We know without adding more capacity to our footprint, current performance is going to decline if we were to use a software-based only solution. For DOE, we have to have a translator and TLS offload, and that adds complexity that we aren't currently equipped to do. That's not what we've been putting our focus on. Now we have to understand that and how to troubleshoot it. We want to make sure that when we offer this, that if we don't know how to troubleshoot it, then we're not going to provide that experience for anybody that's going to use it. We need to make sure CDN location isn't impacted. Geolocation for CDN-based products are a big thing. We want to make sure that our CDN folks are happy and they provide the best quick response to the customers located closely to the customer. When you start translating or encrypting this into an HTTP packet, it's a little bit harder to find ways to do that, but we are working on ways on how we can do that. And there aren't, as I said before, there aren't many tools that are available to do a lot of this testing. We are leaning on you guys, and we're leaning on other vendors and teams on their expertise on to help develop those tools on how to better understand some of the things we don't understand in the DNS team. DNS filtering and enterprise networks. Using centralized DOE can break things. Our customers use an opt-in service, as I mentioned, that does DNS-based malware protection and redirection from known bad sites, and we also offer it for parental controls as well if you wanted to make sure little Timmy can't get to the places you want him to get to and direct them to a block page that Comcast or Xfinity offers. And these are opt-in services for our customers. So when we introduce DOE, this breaks it. This can bypass that DNS filtering, and now little Timmy is on a site that he shouldn't be on. Who's getting those phone calls? It's not the people that have got the browsers. We're getting those phone calls, and that's a big issue. Turning on centralized DOE can allow for someone to bypass those services, as I mentioned. When it comes to enterprise networks, now with split DNS, when you have a centralized DOE solution on, those DNS queries that are supposed to be internal potentially can leak to the DOE endpoint. And depending on where the DOE endpoint is, if it's yours, great, you don't care. But if it's a third party, now there's a way that that data can be enumerated. Turning on centralized DOE, depending on how you have the centralized DOE. One browser has introduced a canary domain that disables the centralized DOE default opt-out service. And that's a good thing, and we have implemented that and tested that internally and did a lot of testing to make sure that the canary domain does what it's supposed to do. It will turn off DOE by default if you NX domain or don't answer, give a no error without an answer to use application DNS.net. And in the other browser, they're going to not change your default DNS setting, DNS provider. I think we just released that we are in Google's experiment, in their new experimental thing for DO and DOT. So we are, as I said, trying to be good netizens and trying to understand this across the board and share their experiences with everybody. DO is our first focus. There are reasons. You guys probably know the reasons. We worked internally. We did a lab week project to create a translator, a DO translator, and we worked with other teams to help make this and see how it works. And then we also worked with other vendors and get their expertise on how we can provide a service. What's going to be the most cost-effective thing? If you bring it internally, or do you ask vendors to do it for you? We want to ensure the good experience, customer experience with geo-load balancing. We want to make sure, as I mentioned before, that we get to the closest DNS response for the customer wherever they're located. We're working on not being reliant on an application or a browser to do DOT or DOH. We're actually in discussions with other teams to provide that for the household at the CPE level. There's always going to be some gotchas with that and how does that work, but we're working with the right people to provide this as another opt-in service for security. Security and privacy is a big thing. It's always going to be a big thing. And we really want to be upfront and show that we really care and we really do want to make sure that your data is protected. And we will have to add capacity during these times as demand sees fit. The tools that I've used currently are DOX, which is like DNS over anything. It's TLS, HTTP, UDP, TCP, and it's got a good GUI front end. You can run it on Mac and Windows. Been using the DO curl client, DNS perf with DOT. One of my setup for DO is I have the DO client running as a stub resolver, and I am using DNS perf to hit that locally with regular DNS queries and use it forwarded to my DO endpoint. And that's one way I've been able to see some of the performance and see where I can break things and give malformed packets and things like that. But this area really needs improvement. There isn't enough. We need people to kind of help out, help some of the open source organizations that do provide some of the tools now, but we need to get plugins for DO and DOT. And if you guys are able to provide funding as much as we're able to provide funding at certain times, we would love to see the community help each other out with this. We have the Encrypted DNS Deployment Initiative, aka EDDI. Yes, it is another mailing list. You will probably get a lot of emails, but our focus is to work together and adopt a new encrypted DNS standards on a global basis. We want to work to improve user privacy and security while preserving the distributed architecture of DNS operations and administration, maintaining global DNS security and stability, and supporting existing DNS-based technical functions. Currently, we have over about 40 organizations participating in this, and there's a few ways to get involved, and you can follow the links on our slides here. And it is a commitment-free, no membership. We're just asking for people to join and share the technical issues that you've run into. We've released, that's where we've announced a lot of our beta stuff that we've been putting out. And in turn, we've seen other organizations releasing their beta for DO and DOT. Some key takeaways from here is we are working to encrypt DNS data. It's not an easy task at scale. It's not going to be an easy task at scale, but we're going to learn and we're going to try to provide that the best for our customers. DO currently has a lot of attention, and it's what we're focused on first. DOT is where we want to go. It's preferred and being worked on in tandem. And as I mentioned, we have the DO and DOT endpoints right there. And we have our beta phase 2 coming up in later this year. And we should come together and push for a decentralized encrypted DNS solution and the best practice and standards. There's a lot of smart people here that already are working on that, and now we need to help push that in this field as well. And the EDI, Encrypted DNS Deployment Initiative, we can use the support from other DNS operators and technical people like yourselves. And these are some links, and that's my slide.
Hi, John Reed, Akamai. Since you mentioned wanting to do encrypted DNS without relying on applications or browsers, what's your story around discovery and bootstrapping stub to recursive?
So there is talks about how to bootstrap that, and we would, at least for our customers, we would find ways to bootstrap that in a way that would keep that data encrypted. To do it across the board for other providers, it's something that's being talked in other in ITFs and drafts. I currently am not involved with any of those, but for our customers, we would find ways to make sure that bootstrap stuff happens in a way that stays within our network.
Okay, so you're focusing really on just within.
Yeah, right now it's focused on how we can do it for our customers, and then we probably be willing on how to share that type of information once we get a better grasp on that.
Thanks. And the second question is, do you see value in doing recursive to authoritative secure transport, specifically DOT?
DOT is most likely the route we would go with that. GoDaddy just released on the forum or on the mailing list that they're doing the thing. We're actually providing testing with them to see how that works.
Okay, so you're specifically interested in.
But we're interested in that.
Great, thanks.
Victor Duchovny, 2 Sigma. I'm curious whether you've heard of the Turis project in Czechoslovakia. They're making a CPE open source box that does all DNSSEC, .do, all the stuff built into the CPE. It might be interesting if you took a look at that.
I have to share that with the right people.
It's called Turis, Turris. The other thing is, I was in Germany last week and talking to somebody. They're looking to see whether it makes sense to move to TCP first by default in DNS. I was a little bit skeptical.
It's very skeptical, especially if you're doing it on the server itself. How's that going to handle that?
Right. No, thinking of changing resolvers to try TCP before trying UDP. Sounds a little scary. I don't know what your thoughts are.
I agree it's scary, and that's kind of when it comes to the DOT and mainly with DOT. We know the DOH, there's going to be more overhead because it's got to do the TLS and TCP and the translation. With DOT, it's a little bit easier. It's just an encrypted packet, but the TCP connections are a big concern for us, especially at our scale. How will our current servers handle those TCP connections? Timeouts, terminations, and those are things that we're looking to do, see if there's any type of kernel tuning that we could do on our servers.
All right. And the last thing is that Paul Wouters, Schumann, and I and some others are looking to see if we can revive the Dane chain extension for TLS.
Okay.
I know that Comcast has Dane, and you guys are using it in email. Would you like to see Dane available to authenticate TLS connections?
Yes, and I'm sure you're familiar with Alex Brotman, and,
yes.
and I am very familiar with him as well. Yes, we would be interested in exploring those things, and going through Alex would probably be the best way to get in contact.
Okay.
Petr Špaček, CZNIC. I will use your presentation for a shameless plug. If you are interested in benchmarking DNS over TCP, TLS, DOH, we are working on a tool exactly for that. It's called DNS Shotgun. It was presented at Tribe 79 2 weeks ago. Have a look. It doesn't have TCP right now, but we are looking for people which will help us either by sponsorship, money or data for testing, servers to run the stuff on. Please talk to us. We can make the tool available. It's open source anyway.
Thanks, Peter.
Hi, David from Alibaba. And my question is, I'm very curious about the performance or the capacity. You show the picture of the volume of traffic, right?
Correct.
If you upgrade all your recursive server, do you have any estimation of
We'd lose about half of. From recent reports and statistics that we put together, we work with other vendors, we'll see with DOT, we would see half of that performance go away. Like, we would go to 300 billion queries. If it were to all be DOT and all the traffic would be DOT. Currently, not everybody's using DOT, so we'd probably see a 15 to 20% depending on what browsers use it, what phones use it, or what customers use it at that time. It's not widely adopted right now, so for those things to be used, you have to physically go in and type in to use those things. But if it were to come on as a default right now in our current infrastructure, we would see half.
Yeah, when we do some estimates of the pressure that when you transfer all your, to recursive, there are no cache between that, right? Mm-hmm. That queries are pulled to a server, so you need to, you need to prepare that. So I would like to ask any research or any estimation, what's the exact or similar to prepare that change? Something like that.
Yeah, that's interesting. I don't know any data on that currently, but I think opening it out up to the mailing list, that the Eddy mailing list would probably be a good place.
Okay, thank you.
Yep.
Yeah, Nicola Leimann, Deutsche Telekom. Quick question: do you support all three protocols on the same servers, or do you have separate servers for?
Currently, it's separate servers. We're for reasons, but we the goal is to at least for DOT and UDP to offer it on the same server or the same sets of servers.
Okay, but for DOH you would see like
DOH
servers.
we might do something different based on how that protocol is used and how we can get better geo off of doing it a different way.
Thanks.
Jim Reid, RTFM. Have you any data yet on the impact of the potential lack of support for ECS from DOE resolver services and the potential impact that has on you as a large operator?
So with the ECS, in regards to ECS, it's always the question that gets asked, especially from our vendors and from other people that use our DNS services. We are working with our vendors to make sure that service is still provided, that ECS would be provided in certain situations. When you turn ECS on resolvers already, you get a cost with how that data is handled, but when it comes to DOE, we're trying to find out a way to do it without enabling ECS, but providing more of a better geo based off of our current footprint.
Okay, I was thinking more from the point of view from what you're doing from a testing and deployment scenarios, if you've got any objective data on the potential volume of queries which are going down, if you like, say, the non-ECS route and if you like, the collateral damage of that elsewhere in your network?
Not right now. I do not.
Is that something you're planning to do?
It's something planned. It's planned to do, but it's right now we're at a functional testing state, and we're trying to get the support from people like you and people like in here to kind of pound on it. I want you guys to go in and break it. I mean, in all honesty, I want you guys to break it and let me know where it broke. And when we did this, when we started this and we did the announcement, we did 6 code upgrades within 2 days. And with the feedback that we've gotten from people, we've at peak seen about 200 connections within the first couple of days, which is quite impressive for people being wary of this of using this as a product.
Okay, thanks.
Yep.
Thank you.
Thank you.
Thank you, Joe. Also, don't forget to rate this talk, of course. Up next, we have Christian Petrasch from DNEC, and Christian will talk about their high-performance signing cluster. Oops.
Thank you.
Yes, my name is Christian Petrasch. I'm the product owner of the zone signing team at DNS in Germany. And I will show you our new zone deployment stuff. The motivation to do that was that we had zone updates one every hour, and we want to speed up that. And we want to simplificate the key management and automate that. And we want to think about a more cost-effective solution for HSM as well. And as you can see, we thought about maybe it's possible to make it capable to do signing for other zones. So we had the proprietary signing solution, and we had the key ceremony like the IANA process. It's a little bit complicated because it's every 3 months at DNS, and there are different people. And you're maybe once a year, and the people are losing their passport and so on, and it takes a lot of time. So maybe there are better options. And overall, we have locations far away, like Korea, and an increment for the whole signing zone. It's around 300 megabytes, so it takes a long time to transfer that. So we had a lot of wishes, what we can do, and the 4 basic wishes were sign incrementally, communicate through standard industry protocols like IXFR and dynamic DNS and stuff, and use a solution which is open source and community based for better support. And it should be a redundant, a product with redundancy, so it's a cluster solution. So we had a bunch of possible products we can use. And at the end, we decided to run it on premise. There was a discussion to run it at the cloud. And we use Kubernetes because there are good advantages for container technology and microservices. There are a lot of redundancy features, and maybe a cloud migration is possible as well. So for the communication, we are using JSON and dynamic DNS. We are generating with a Python tool JSON messages and send it via the dynamic DNS to our signer. And for signing, we have chosen not DNS, mostly because it's really common in the community now for signing, and there was a possibility to make it really fast through the last half year. As you can see, it was, at the beginning of the year, it was around 400 seconds for our big zone, signing, sending a new domain inside, signing it, and transfer it to the next server. And until July, it was something around 15 seconds. So it was a tremendous performance boost they could reach. And at this point, special thanks to the main developers of NotDNS, Daniel and Libor. And we had a direct communication with sysadmin, so it's really nice to see to get the problems fixed in a proper way and in a fast way. And the experiences RIPE NCC shared with NotDNS was also one of the key features why we thought, okay, let's do it with Not. We had a lot of challenges during our journey, and one challenge was at first thinking about a message queue to send the updates inside and queue the stuff. But one problem was that the message queue, we used Kafka, wasn't really fitting well in Kubernetes. There are some issues running Kafka in Kubernetes. You can do it with a load balancer and it's working properly, but if you don't want to have such a mighty construct, then it was a better idea to queue it in the database and reverse the push-pull mechanism. And now we are pulling the data out of the database. One of the next things was how to sync the key material without an HSM. So we used the cluster file system-based solution. And a Python tool, as I said, to provide the updates. Here's a little scheme how the data is coming to our registry system. The domain owner is registering the domains, and it goes to the registrar systems, to the DNS-OARC, it's like EPP, and the database. And then the tool which produces updates for our signing cluster fetch it, and then it's grabbed by the signing cluster. And here's the basic first scheme of the signing cluster. We grab the data from the registry and pulse the JSON data. And it's a Java-based tool. We call it DNS Update Gateway. And then it sends to the not-DNS signer, signs the increment, and put it out via IXFR to the world. But there were more challenges because our tool is able to handle maybe 1,000 updates in one JSON message because of the size of the packets. So we have 16 million domains in the zone, and at some point you have to fill the whole zone into the signing cluster. So it takes too long to do that with single JSON messages. So we developed a tool which can provide the whole zone to the signing cluster. And that is a scheme I showed you, and now we implemented that. It's it's a new service we implemented, and the zookeeper key value store, because we have the issue that during the initial filling the cluster, you have to stop the update gateway sending updates, because it's your chain will be broke. You are losing updates if you do that during the initial filling. The next step was, in the past we were doing zone validation with ValidNS. We were sending, we are generating a zone, then we send it to a name server and check it with ValidNS, and then if it's valid, we send it out. The problem now is it takes too long. We want to have a domain inside in several minutes in our name servers, and if we do a validation process, that takes maybe 7 minutes, so it's too slow. So we thought about, okay, we will do it asynchronously. And if we find an error, we stop it once. Then we do another zone initialization process, check the zone as well again. And if it's green, we say, okay, let it roll forward and everything is fixed. If it's not, we stop everything and a guy has to do something. But at the first time, an alarm is sent as well. So somebody will take care about the issue. But the chain is running again. And we will do these checks every 30 seconds. But it takes several minutes to do, so it tries to check the zone every 30 minutes. At this point, we are in talk with NNet Labs to create an incremental validation tool. And for that, I'm searching for interested people. If there's somebody in the room, come and talk to me. I will provide more information, and maybe we can do some stuff together. I will show you the process like I have described it. That is a new process, as an implemented process. We have this checkzone pod, and it writes in the zookeeper, okay, do I have a validation error or not? And if there's a validation error, there is the init zone triggered, and the init zone is triggered by the signer pod, because if the signer pod is killed and running up, then it generates a new zone. And everything is controlled by the zookeeper. There in the zookeeper are the data inside where the pods know, am I able to run? Should I do something? And we can control the whole cluster and orchestrate the whole cluster. One thing is Kubernetes is not really built for have one active cluster and one passive cluster. That is a little bit tricky, because with a signing solution generating keys for itself, you can only have one position of truth, where only one signing cluster can generate the key material. If you generate key material in both locations and you synchronize that, you destroy it. So with that, okay, we need a key value store to control that, but outside of the clusters, both clusters has to be the possibility to read from that key value store. And we have done that. We use it for our database as well, to control our database, by the way. So we put the information inside this etcd key value store, and both clusters are reading. Okay, am I the active cluster? Then I will sign and running the signer. If I'm the passive cluster, I will be inactive and only grab the key material to be ready if I'm triggered to run. So the last point we had to mention about was the HSM solution. What we require we have, as I said, 16 million domains, and it's around 10% signed, so it's 1.5 million signed. So we need a high-performance signing solution, and it should be sufficiently secure. Sufficient secure means we have done security evaluation of our signing equipment as we started with DNS-OARC in 2011, and we had a list of criteria, and we compared the new signing solution against a signing solution we had in the past, and we have done penetration tests as well. So it should be PKCS 11 capable because of industry protocols, and if possible, for sure, economical. So we looked a little bit around, and our friends from RIPE NCC, for example, they use no HSMs anymore. And so we said, okay, maybe we can do that approach, and we make it everything secure. And some people in the community I heard was that HSMs are a little bit overkill, and maybe it's a better way. And we have done a survey as well. And mostly we heard, we have offline KSK without HSM, or online KSK with HSM. And we thought, okay, we will do the REP NCC approach, and that we secure the cluster, and we have no HSM anymore. But our management said, maybe it's not a good idea to put the key material on the hard disk plain text, so we can use two products. Maybe it's soft HSM or the smart card HSM's USB tokens. But the smart card HSM USB tokens, we tried around in the past with that, is too slow. So we said, okay, Soft HSM version 2 is a good option. Soft HSM 2 has a possibility to generate tokens which are AES encrypted. So the key material is not in plain text on the disk. And you have a secure cluster, and everything is fine. Oh, we hope everything's fine. What we do for security, a little overlooked because I can't tell you so much because it's for safety-related reasons. I can't say what we are doing, but it's a role concept, analogous key ceremony to access the cluster. We have firewalls, and we have a good monitoring to see if something strange happens. And so we think if you control the environment around the cluster is enough to make it secure. So I will try to show you a demo, and so we have to switch to my laptop. Yay! So maybe someone can provide me a number. It doesn't matter which. 42, okay. So I register the domain with the number 42 in our system. Now you can see it's registered, it's green. And now I'm starting the stopwatch. And that is one of our name servers. It's a testing name, so we want to go productive at the end of November. So I try to ask the name server for the domain with the number 42, and then I think it should be around two minutes with our big zone when the domain is available to query at the name server. So yeah, that's everything from me. And if somebody has questions, I think it's possible to ask now, meanwhile.
I remember Peter Koch some time ago saying that ECDSA wasn't an option for you guys because it doesn't generate predictable signatures and something about signing clusters and getting different answers on different machines. Is that resolved with this new architecture? Are you now able to do ECDSA? Have you switched to deterministic signature generation, or it's not an issue anymore? Or?
I think it depends a little bit more what not is able to do, but I think it's fixed. Yeah.
Okay.
Okay,
So
but at the moment we are using RSA, but we want to do ECDSA in future. Yeah.
Okay. The other thing I'd like to encourage you guys, I know not many registries as yet support CDS. It's just, as far as I know, Switch and CZNIC. Are you guys looking to do CDS support? Because DNSSEC deployment in .d is pretty light, right? 200,000 or so domains at the moment out of 16 million. It would be nice to see that go up.
Not at the moment. Yeah.
Okay.
Hi, this is Audrey Suri, IC. I can answer the question about the NodeDNS because NodeDNS uses GNU TLS, which has the deterministic signatures generation for ECDSA, and the projects using OpenSSL don't have the thing because OpenSSL doesn't have yet the API for the ECDSA deterministic signatures.
Cool, thanks. Yeah. We are done. And so my management says we want 3 minutes, though I think it's 2.5. Cool. That's all from me. And
Are there any more questions for Christian? Thank you.
Thank you.
Right, so I have a couple of announcements. First of all, I would like to thank the OARC 31 associate level sponsor, which is Comcast. And I would like to thank our annual patron for 2019, which is VeriSign. Once again, a request to rate all the talks we are having today. It does help us in creating a better program. So you can find the link to the survey on the OARC 31 webpage. For tonight's social event, we still have around 20 tickets available. So if you haven't registered yet and you would like to join, to register as soon as possible. We have a hard registration deadline at 3:30. And do note that +1s can also register. For lunch, we have options available for those who are vegan, vegetarian, or have allergies and have stated so on their registration. There is a fixed number of all these options, so keep that in mind, please. And the lunch will be served on the other side of this room, behind the curtain. You can get there via the hallway, past the registration desk, and then via the double doors. Enjoy your lunch, and we will be back here at 2.